Using CoCalc allows us to program in Python online without having to install software. Let's take a quick overview on different ways we can run Python code on CoCalc. Firstly, we look at Python scripts, and as always, a Python script is simply a text file. And here on CoCalc, we'll open up the text file and we'll add some code, and we will then learn to run it. So to create a text file, hit create, and here you can make any file of your choosing. A Python file should end in .py. So once we add the file extension .py, we hit the file button. And now we have a text editor where we can add any text or code we wish. So here again, we'll just simply do a hello world test code and followed by some simple arithmetic. As with any text editor, you'll find many options in the toolbar for copying and pasting and searching, and you can already see that there's very useful color coding for your code. So here we'll simply print the final value. We'll save the file by clicking on save, and once we've saved the file, we would like to run it. Now, to run a script, you need to ask Python to run it, and this requires a command terminal. So let's create a command terminal in CoCalc. This is something we can reuse again and again. So give it any name you want. I've called it term. Hit terminal, and now we've got a command terminal in our home folder on CoCalc. So we can first just do a simple command called ls for list, and it will list the files in our current directory. Now we can run Python followed by the file name, and we now can see that it runs the code. Next, we will quickly check a more detailed bit of code. This is the other example we'll use to calculate the Lorentz factor or gamma factor, which we use a lot in physics. So here again, we'll simply put our example code in very quickly, copying and pasting it into the text editor, press save. And once we've saved it again, we can simply click back into the command terminal, list what files are in that directory, and again we see our new file is there. Python 3 followed by the file name should run that file. And the example I want to show here is that you can quickly flick back into that Python script, modify it or change it in some way, and save it and quickly rerun it. So you can have a pretty fast workflow by changing between the text editor and the command terminal. Next, we will look at how we will use the Python interpreter on CoCalc. This is another option you can use, and it tends to be an option to enable you to quickly check whether basic or more advanced Python code is working. So as before, we will go to a command terminal and simply type Python 3, and that will immediately take us into the interpreter. So our command terminal is still there. Typing Python 3 and return should enable us to go directly into the Python interpreter. Now we can type any Python code we wish, and if there are no errors, it will of course run, and it enables us to quickly check code line by line. So our default example, hello world, is working, and our simple arithmetic is also working. So this should be a place where you can go and quickly play around with some ideas you may have with some Python code. Here we print out the value C, and we can quickly check also whether A plus B also works in the same print command, and it does. So it's a useful means to quickly check ideas in coding. To exit the interpreter, you go exit, double brackets, and now you're back into the command terminal. Lastly, and perhaps more importantly, we will look at the notebook option for using and running Python code. This notebook is also referred to as the Jupyter notebook or IPython notebook, and the file extension is IPYNB for IPython notebook. So creating a Jupyter notebook is very, very simple. We will show you in the next video. It essentially means creating the file name, and again, try to avoid spaces in your file names. This I will simply call notebook. We click on Jupyter Notebook, and that leads us into the notebook file. If you're new to Jupyter Notebooks, it consists of cells, and this is a first cell. There's nothing in it, and I can choose to add either text or code to each cell. In this example, I will add text, and the text I will click to Markdown. The next cell, I will add some Python code, and in this it will be again our example test code for hello world. And the difference here is that, as you can see in the drop down box above, the cell is defaultly in code. So you run the code by pressing the play symbol or simply Control and Enter. Next we will add our more advanced script for calculating the Lorentz factor. And again, you see it's nicely color coded to enable you to see functions and variables. Again, you can quickly change, as you would do in a script, variables on the fly and rerun your code. And indeed, the Jupyter Notebook is a very good combination of what you get from a script and an interpreter, in the sense it enables you to quickly run code and test and visualize the output. The notebooks were also very advanced media documents that can hold audio, video, as well as rich formatted text using a LaTeX type language called Markdown. And later on, you may also decide to write documents in these notebooks, and that will be comprised of titles and subtitles and mathematics as well. Here's a quick example of some basic mathematics with an inline equation. But as we go forward, we will learn the full potential of these notebooks for creating very rich scientific documents.